for the purpose of those that are just
The only competition is you.
joining my class for the first time.
I don't
I
feel the
am
pressure.
Abdubaki Olawi, and I start with the module 2 on Thursday, where we discussed extensively on the hardware parts of PLCs. We talk about the architecture, the types of PLC, the brands of PLC, and then we also talk a little bit about PLC programming logic. Today, we are going to be concluding the module 2 with the concept of syncing syncing and sourcing. Okay, and what that means to you wiring your devices to the PLC. Okay, so from the name, sourcing and then syncing. Sourcing already is telling you like that looking for something, okay, and then syncing is like uh giving something out or ending something at a particular point. Okay, so now how does it apply to your PLC devices? Okay, so syncing provides a path to the supply command. In this type of circuit, when the button is pressed and the contact close, current flows from positive to negative into the PLC as an input. Uh, the common supply in this case is negative, making this a syncing configuration. Okay, now if you look at it, how does current flows? Current flows uh, from positive to negative in an electronic or electrical circuit. Okay, so for your input or your output, when it comes to a syncing configuration, you will realize that your uh, your device is the channel through which the positive signal enters into the PLC. It serves as the medium for positive signal to enter into the PLC, while the PLC already holds on to the negative signal. You can see from the diagram on the screen right now, the green arrow is pointing, it's coming from the cell, the battery cell, and then it's going from that point into the switch, and then from the switch it's entering into the PLC. Okay, and already in this configuration, the PLC already have the negative signal supplied to its common. Okay, so you can say that your device is syncing into the PLC because the positive of your battery cell, let me use that word, is ending into the PLC. It's not as if it is coming out of the PLC. Okay, so your device is syncing into the PLC. So um, for the same thing for your output, you can see it's still the same flow. Okay, on the output side, the syncing output module allows current to flow into it from the load. So this is achieved using the NPN transistors for switching. Okay, so uh, your syncing output too, the it is through diodes the load that the positive signal enters into the PLC, and then the negative state stands as the common. That is for sinking. So the opposite is what you have when it comes to sourcing. So in the opposite, you will realize that your your device uh, ends up in the negative side, and then the PLC is now going to be the one giving out the positive, while the negative end of the circuit enters through the PLC through your device, either input or your output. Okay, so here is an example here. So you can see that uh, what was supplied into the PLC is positive. The common of the PLC is positive. Okay, and then the positive enters into the PLC, then it comes out to meet the switch, and then comes back to close the circuit at the negative end of the power supply. Okay, so that is how sourcing works. So the key question in any DC IO circuit: which direction does current flow through the module channel? This determines whether you need a sinking or sourcing module, and which sensor type, NPN or PNP, is compatible. So now when you have we have different modules, type of modules. They call the modules can be
So
syncing type.
pure PLC to this morning.
Please, can you mute?
Please, can
It
you mute
started
yourself? Please,
on this
please mute
Tuesday.
yourself. Except that
I'm not doing anything like this.
if the
Let's not
admin can mute everybody, it
on
will be better.
YouTube. Okay. People download that from your
Mr. Elsberg, please shut up. Mr. Elsberg.
They started already. I don't know. I won't follow one now. They don't do attendance. I bet I don't do that. Because I don't miss out of them. The other one, my batch don't live, don't like so you don't drop food for attendance. Now, so on Thursday, so
All right, I guess we are back. Sorry for the interruption. Okay, so there are some PLC modules that you will see, and it will be stated on them that they are syncing type module. There are some that will let you know that they are also they are sourcing type module, and there are some modules that can be either of the two. Okay, such module, you are going to be seeing something like S/S on them. You see that more on compact modules, on compact PLCs, majorly from I've seen something like that with Allen Bradley, Mitsubishi. So you will see something like S/S on that particular PLC. When you see S/S, so what they're telling you there is that they leave the choice to you to either use it as a syncing type module or a sourcing type module. Okay, so it all depends on your choice at that particular point in time. Now, let's uh, let's look at the wiring of a syncing module and a sourcing module. Now, for a syncing module, current flows into the module channel, while for a sourcing module, current flows out of the module channel. So, which means that also for a syncing module, the positive terminal of of your PLC is always okay. Sorry, for your sync. Let me focus on syncing module first. Then we go back to sourcing module. So for a syncing module, current flows into the module channel, and the COM terminal connected to 0 volt. So either you have a load or a uh, an input, in this case an input device. The positive the one terminal of the switch will be connected to the PLC, while the other one will have to be connected to the common. Then for your power supply, the PLC will be supplied with 24 volts, and then the common will be supplied with negative 0 volts. So if you look at this circuitry on the left hand side for the digital input syncing, you will see that the power supply is connected to both to the PLC. The both end of the power supply is connected to the PLC. One the positive terminal and the negative terminal. The positive terminal is connected to one end of the PLC, and negative terminal is connected to the common end of the PLC. Then you now bring in your sensor, in this case a PNP sensor. It is connected to the PLC, one terminal of the PLC, and then the negative end of it is connected to the common. So it simply means that for your sensor now, it's going to be taking its positive from the PLC. Okay, it's going to be taking positive from the PLC, because so sorry, it's going to be supplying positive into the PLC, and then hold on. Okay, so sorry, um for the syncing, like I was saying, the positive terminal, uh the diagram we are seeing now is actually talking more about the sensor itself, the PNP sensor. So you are going to have three terminals on that sensor: the positive terminal, the 0 volt, and the one that is responsible for the signal. The brown 24 volt, the blue 0 volt, and the black for the signal. Okay, the black for the signal will be connected to the signal part of the PLC. That is where it is going to be supplying command into the PLC to tell the PLC whether it is sensing or it is not sensing. Okay, so and the negative terminal of it, which is the blue 0 volt, will be connected to the common of the PLC, while the other end, which is the brown, will be connected to the positive end of the power supply, which will also be connected to the PLC. Okay, so now the positive will enter into the PLC through that sensor. Um, so it's going to be syncing into the PLC. But on the other end, for MPN, you will see that common for the MPN is connected to positive. Okay, and then the negative is connected to the P to the upper terminal of the PLC, and then it is also connected to the sensors, uh, the sensors, it's connected to the sensor, and then the signal is connected directly to the PLC. In this case, when you look at the flow of current, you will see that positive is flowing from inside the PLC down to the sensor, and then the circuit got closed out at the common end. So at this point, you will say that the sensor is sourcing, yes, it's sourcing from the PLC, and it's sourcing from the PLC while the sensor is syncing the PLC. So this is where the confusion used to come in. Okay, so apart from the fact that your module can be of syncing type, the devices that you have too can be of that type. So if you look at the other end, or if you look at the left hand side where we have the digital input syncing, we see that your module at that point is serving is a syncing module. However, the sensor is sourcing. Okay, so whichever one, where if you look at it very well, for this sensor, which is the PMP, it is it is sourcing. Okay, it is sourcing. What is it? Okay, it is sourcing. Why the PLC is what? PLC is syncing. Okay, so sourcing is where is the positive signal? Where is it coming from? That is where is the direction of flow? Okay, if you look at the uh the PLC, it is receiving signal from the sensor. The arrow is pointing into from is coming from the sensor into the PLC, which makes the PLC to be a syncing a syncing module. Whereas in the case of the sensor, it itself is sourcing. For the other end, where you have the digital input sourcing, the PLC is what? Is giving the signal is flowing out of the PLC, okay? Which means the PLC is being synced. The input is sourcing from the PLC, while the input is sourcing from the PLC, while the PLC is being synced into. Okay, so that is the dynamics. So when you have an input that is sourcing from PLC, the PLC will be syncing to it. It will be the opposite. But when the PLC is the one sourcing, the input will be uh will be syncing. Okay, I hope that explanation is clear. Is there any clarification before I proceed? Okay, if you have any question before I proceed, please indicate by raising your hand.
Hello, sir.
Yeah,
Good morning.
good morning.
Okay, thank you for this session. Please, I have a question on the wiring system.
Okay.
With the 24 volts, is it the power supply that's the power supply module? That's where it's coming from, right?
Yeah, it's coming from from your power supply.
Okay. I'm confused with the wiring, like how it will be wired. That is where kind of stranded.
Okay. So basically, on your PLC module, there there will be labeling in there as well for you, okay, as to maybe you are supposed to be positive here, or maybe this is supposed to be common. Are you with me? So let's say, for example, uh this, I hope you're seeing my screen. This is your PLC. This this place that is circuit that you have PNP inside it is your PLC. This is your load, and this side where you have the positive and negative is your power supply. So basically, there is, I don't know why my cursor is not showing. Okay, seconds. Okay, no wahala. So um look at this now. This is your power supply. This will be your PLC. This will be your load. Okay, so let's assume that the load is also 24 volt. This is also 24 volt. This power supply is also 24 volt, and this module 2 is also 24 volt powered. Okay, so now you notice that your positive is connected to common here. All right. So it means that as far as the PLC is concerned, any form of positive that it needs at this particular is already terminated here for its use. Okay. So, and within inside the PLC, it can give out the positive. Okay. And then the last end of the load or the switch, whichever one, will come to the power supply as negative. Okay, to complete the circuitry. So this power supply in itself can be within this connection can be within the PLC alone, and it can also be from an external power supply. Okay, so if it is from an external power supply, definitely there will be another terminal that is dedicated for you to connect this negative power supply on the PLC, so that there will be a separate terminal that will be for the power of the PLC that you supply your positive and negative 24 volt to. Okay, so now, but this basically has not this wiring that you're saying now is not talking about how you power your PLC itself. It's talking about connecting a device to the PLC. Okay, so it's assumed now that your PLC is powered. Now I have a switch or I have a bulb. How do I connect it to my PLC? In this case, you your PLC, okay, is sourcing for its positive from outside, which is where this common is which is why this common is sending in positive into the PLC. In this case now, your load is your load is sinking into the PLC because the is sinking into the PLC, because when you look at the flow of signal, how it gets into the PLC, uh, sorry, how it gets into the PLC, this is the flow of signal from the load into the PLC. So in this case, it's sinking into the PLC, while it is in this direction is sourcing from the PLC, sourcing and then sinking into the PLC. Now, if you look at the negative end is connected to the load, the common comes into the PLC. So for the load now, the positive gets its positive from the PLC. So if you have a switch that or a bulb that you want to connect, in this case, you connect the one leg of it to the negative of your to the negative of your power supply, and then the common uh, and then you supply the common of the PLC with positive volt. Then the other end of your load will go into the terminal, which is responsible for giving signal to the load. Okay, so when it comes to uh, syncing as well, you see that in this case your load is sourcing from the power supply end while it is sinking into the PLC. So it is sourcing by the flow of the current. That's what you use as the to determine the direction. So where for this now you can see that your load is sourcing from the power supply while it sinks into the PLC. Okay, in the case of the PLC2, you see that it's sourcing from outside while it sinks back into the power supply. So if you have your load that you are connecting, in this case, positive end of your power supply will be connected to the load, and then that load will be connected into your PLC, while the common, in this case, will be connected to the negative of your power supply. So, but when it now comes to your sensors now, you look at it. If you look at these sensors now, in their own case, they are in this case, you see that signal is flowing into the PLC. So you can see that it's, if you look at it from the power supply end, signal and this, of course, the sensor is in play here. So the signal is your PLC is sourcing from your sensors and then sinking out into the power supply. But for the case uh of your sensor, you can see that it is sourcing from the power supply while it is sinking into the PLC. Okay, it's sourcing from the power supply and then it is sinking into the PLC. So if you look at this end, you will see, based on the flow of signal, that your PLC is sinking into the sensor while it is sourcing from the power supply. But for your sensor, it is sourcing from the PLC while it's sinking back into the power supply. Okay, so I don't know if that explains the question you were asking. So basically, this is a typical example of how you are going to wire your sensors or your load or your push button or switches to the PLC. However, it's always recommended that you go through the manual of whatsoever PLC that you are trying uh, to to wire. So because in there you will have the wiring diagram that give you an idea of how this is to be wired, because it is not always written. It may not be, let me put it this way, it may not be written on the PLC that, okay, this PLC is syncing type module, or it is sourcing type module. It is when you now go into the manual of that PLC that you get to see, okay, based on the wiring diagram, I think this PLC is syncing type, or it is sourcing type. Then you can now be able to use the information in the manual to do your wiring. I hope that is clear.
Yes, sir. And I have an additional question. I don't know whether I can ask.
Okay, go ahead.
So in case you have a PLC model that is already a sinking source, and
Okay.
you want, as you said, you have to wire it with uh the sensors and other stuffs. So
Okay.
but you have a sinking model, but the sensor that you are bringing to is a sinking model. So in that case, how do you go back?
Rephrase that question. I don't think I get it well.
I'm saying in the sense that the the PLC model is a sinking model, and
Okay.
you are bringing in another sinking sensor.
Okay.
So how do you go by it?
Okay. So, um, when you, if I get you correctly, hold on. If I get you correctly, you are saying that if you have a sinking module, okay, and then instead of having a sourcing module, like this, you have the opposite. Like you are saying, if NPN is put in this place instead of PNP. Am I correct?
Yes, please. Yes.
Okay. So now, if you have it that way, you can still uh, make use you make use of the configuration of the PLC itself. You respect the configuration of the PLC itself. At the end of the day, what might change is how the sensor will respond will respond to uh, the sensor. Okay, so for example, if you look at the wiring of the sensors on this, you will realize that despite the fact that they are syncing or sourcing, you see that the brown still remain 24 volts, the blue still remain 0 volt, and the black still remain the signal. So whether it is NPN or PNP. So when you bring it into this setting now, you still connect it as though you are connecting your NPN, because what you are going to supply to the common here will still be negative, while you supply the positive and all for your for your PLC. Okay. Now you connect it the same way, but take note of one thing. When you are connecting the syncing PLC, your uh your 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 blue is switched with the orange. Am I correct? So the orange still go to sorry, the brown, the brown still go end up on the positive end, and then the blue ends up on the on the negative, which is 0 volt. It's still the same thing that will still happen when you are making your connection. Even if you look at this side, it's still negative that ends up. The blue still get connected to the negative end, and the brown still get connected to the positive end. You will see that in either of the case, the connection of the sensor to the power supply or the PLC still does not change at any point. So you still maintain the normal wiring that you have. Your blue still goes to negative, your brown still goes to positive, and your black still go to the signal of the PLC. So, but uh, as you may note that the brown now in this case, the brown in the case of bringing the syncing to this point, you will not connect this uh blue. The blue is positive for a PNP, but it is sorry, the blue end is connected to negative for PNP. Same thing for NPN. The blue is connected to negative. The brown is connected to positive for NPN. The brown is also connected to positive for PNP. So it still remains, the wiring still remains the same. But now, where you now have to look into is the PLC itself. So like I said, the configuration on the PLC end will stand. So you still connect your negative to the common, okay, and then you connect your your signal, the black cable to the signal of the PLC, and then the brown to the positive. So the configuration still remains the same. Are we together?
Okay. Yeah, thank you. Thank you very much.
All right.
All right. Thank you, Mr. Abdulbaki. Can I go for my question?
Yes, sir. Yes, sir.
Okay, so my own is just to be sure I catch the concept.
Okay.
So in the case of Flex 5000 IO card, where
Okay.
on the terminal the card is getting supply from another source,
Okay.
the positive and the negative. And on
Okay.
the CAT terminal, we have the 24 volts, the common, and the signal. So
Okay.
if you are connecting a sensor, the 24 volt of the sensor will be connected on the 24 volt on the terminal, then the common, and then the sensor. So I just want to be sure if this kind of module is because based on what you explained now, I want to take it as a sourcing module. I don't know if I'm correct.
Okay. What makes it a sourcing module is that you are connecting your positive is coming into the PLC directly.
Yes, the positive of the sensor is connected to the positive terminal of the on the CAT terminal on the CAT on the terminal rail.
The positive of the sensor is connected. How many wire sensor?
Like three wire sensor. So let me
Okay.
just rephrase. What I mean is the CAT is getting supply from another source,
Okay. From another
and
power
then
supply.
yes. So
Mm-hmm.
the on the card itself, it has three terminals, connecting terminals. One for 24 volts, then we have
Mm-hmm.
common, then we have signal.
Mm-hmm. All right.
So so if we are connecting a three-wire sensor, those three cables they will be connected to those three terminals.
Okay.
So that's
So
why I'm saying, okay, yeah, go
so
ahead.
in that case, your PLC is serving as a power supply as well. You get you
Yes, yes,
are you getting my point? So it's
yeah,
not a configuration where we are considering that okay, you have an external power supply like this one. Okay. So your PLC in itself is having a positive 24 volts and negative terminal. Okay.
yes.
So which means that in the your signal goes directly to the signal terminal of the PLC. Then your
Yes,
the positive of your sensor goes to the positive terminal on the PLC, and then the
yes,
negative goes to the negative or common terminal of the PLC. Okay, so
yes.
now what's the question here?
No, like I want I want to be sure of if I understand the concept that this kind of module is a sourcing module. Is it correct?
This kind of module is a sourcing
The,
source.
yeah, like the module that I explained now, can it be a sourcing module?
So which um what is common to the PLC and the sensor?
Like the common
What is
terminal?
common to the what is common to the PLC? You know, the three what is common to the PLC and the sensor?
Okay, if I understand you,
Mm.
the the power supply that is coming to supply the card is still the same power supply that is going to the sensor.
Okay, so from my explanation that the flow of your current is what shows what your PLC, what your module or your signal is doing. So if you look at this now, they call this digital input sourcing because it is sourcing the positive signal is entering into the PLC directly here. Okay, so
Yes.
it's entering directly into the PLC here.
Yes.
Are we together? So this
Yes.
is
Yes.
sourcing. This module is sourcing from outside in this case. Now, in this case, it's not your the positive is entering into the PLC, okay, through the sensor. So the signal is entering into the to the PLC through the sensor, and then the negative is coming out of the PLC, which is why this module is considered a syncing module.
Yeah, okay. So in the module that I'm talking about is
Okay.
more of this sourcing module because the power supply the module is the one sourcing for the power supply from another source, and then
Okay.
the from that particular supply to the module, that's where we now take 24 volt to the sensor.
So you may not be able to tell directly because from what you explained earlier, you connect both 24 volts and 0 volt into to your PLC. Your PLC gets powered by 24 volts and negative 0 volt. Okay,
Yes, yes,
so
yeah.
and your sensors, every cable of your sensor are connected directly to the PLC terminals.
Yes,
No external
yes,
power
yes.
supply in that case. So you cannot be able to say categorically that that module is sourcing, except you have in your wiring, in the wiring diagram of the PLC, when you check the manual, if you see this kind of configuration in there, then that's when you can state that it is sourcing. It could also end up being syncing.
Okay, okay, then I understand your point. So
All right.
let's just continue. I will go back to the
Okay.
manual, then I'll get it more. Thank you.
All right. You're welcome. Mr. Philip?
All right. Good morning. Thank you uh, for the exposition. Am I audible?
Yes, you are.
Okay. You mentioned at introduction that um, the syncing or sourcing of the module will determine the type of sensors that will work with it. And I think maybe I stand to be
Okay.
corrected. I think you mentioned along the line that if um, if the module is the sourcing type, then you should use a syncing sensor with it. I stand to be corrected.
Okay.
So the question, okay.
Okay. Continue. Continue with your question.
So the question that relates much with this, when someone was asking the other time, is if you have a sourcing module and then you have a sourcing sensor, that's um, how is it going to respond? So I'm trying to
Okay.
ask from the aspect of, I think, is it that um, there's a, I think I think you mentioned something earlier that it's like a standard that has been provided that if it is a sourcing module, then this is what you should use. I think you should just help to expand a little bit on that. If maybe there's a standard procedure that says if the design says it's a syncing module, okay, basically this is what you should use for it based on the design.
Okay.
Thank you very much.
All right. Let me first clarify. I mean, maybe I mentioned it that way or not. I can't really recall. But if first clarification is that your PLC module does not necessarily uh, decide the kind of input or output that you can connect to it. If anything, or what I'm trying to say at that point is that the type of module you have determines how you are going to wire the module itself. Are you with me? So now the uh, whether you have a syncing input module or a sourcing output module, you can still connect a syncing or sourcing input into it. So you can still connect your NPN sensor to a syncing module. You can still connect your PNP sensor to a syncing module. Also, you can connect your NPN or PNP sensor to a sourcing module. So whichever one you have, you can still use it for any module that you that you have. So, but when it's you just cannot go and be wiring uh, um, based on what you are saying on the sensor. You need to on the module. You need to be sure if it is not written on it. That's why I was saying that the manual needs to come handy so you can check the wiring diagram inside the manual to know how am I going to go about uh about the wiring. Because if, for example, you have a syncing module and then you wire it like it's sourcing, you are going to have a issue. Okay, so for example, instead of connecting my common to negative now, I connect positive to it, and then this end that I'm supposed to connect to positive, I now connect it to negative. There is definitely going to be an issue with it. If you don't even have a spark, your device will not respond the way it's supposed to respond. So what I'm trying to say at that point was that the kind of module that you have will determine how you're going to wire the module itself. So you can still have a syncing module and then connect your syncing your NPN and PNP to that same module. So are we together? So, and then you can have a sourcing module and still connect your NPN and PNP mode, a PNP sensor to that same module.
All right, thank you very much.
Yes. Okay. I think.
Um, good morning, sir. Please, I have a question.
All right.
Okay, so I want clarifications on the active state of the signal sourcing. So in the sequence, I say that the active state is like the low signal. Then while for the sourcing, the active state is high, 24 volt. Does it mean that when the syncing set sources 0 volts, that represents like a binary of one, like a true value?
Come again.
Like I need clarifications on the active signals on the syncing and sourcing module. Because on the syncing module, it will say that the active signal is low, a signal put to 0 volts, while for the sourcing it is 24 volts, signal put to 24 volts. Does it mean that when the
Mhm.
syncing PLC sees 0 volt, it means that that's a true state of one, of binary one?
I don't think I get your question very well. Please come one more time, please.
Okay, so like I'm need clarification on the active signals of the
Okay.
syncing and sorting module. Because from the slide here, you'll see that the active
Okay.
signal is low. That's when the signal is put to 0 volts. While for the
Okay.
sourcing, the active signal is high when the signal is put to 24 volt. Does it mean that for the
Okay.
syncing digital input, that when it sees a signal of 0 volts, that represents a binary value of one, which is true?
When the PLC sees a signal of 0 volt.
Yes, sir.
So if you look at the true circuit at the end of the day, see the signal is from this end now, positive is flowing into the PLC, only for the PLC
Okay.
to come and complete the circuit here. Are we together?
Yes, sir. Yes, sir.
If you look at this end also, positive is still flowing into the PLC, only for them to come and complete the circuitry at the negative end here. Are you getting it? It is not at any point so that negative is moving around or something. I hope that I hope you get the point that I'm
Yes,
trying
sir.
to make here. So
Yes, sir.
as the case may be, let's say for your PMP now, okay, it will be such that in the situation where it is not seeing anything, okay, signal is not going to even flow into the PLC. Are we together? So by the time it's seeing something, signal is going to flow into the PLC. Are we together? So as the case may be, let's say for your PMP now, okay, it will be such that in the situation where it is not seeing anything, okay, signal is not going to even flow into the PLC. Are we together? So by the time it's seeing something, signal flows into the PLC, and then the circuitry becomes completed at that particular point in time. Or in the case of the MPN, you see that because the positive the signal is flowing from outside into the PLC, it will be such that at this particular point the PLC may not be seeing a one, and then by the time the sensor is saying something, the PLC will not be seeing zero. So in this case, it's not about the PLC having one or zero. It's not about the power supply or the power or the terminal you are connecting to it. It will now be dependent on the sensor itself. So is the sensor saying something? Okay, send signal of one. If it is not saying, send signal of zero. For the MPN, if it is saying something, don't send the signal of zero. If it is not saying something, send a signal of one. I don't know if that explains it.
Okay, yeah, so that clarifies this. Thank you very much, sir.
All right. Okay, so I guess there's no other question, so we can proceed with the class. So, last on this module, we are going to be looking at the analog signal standards. So you can have a variety of signals, electrical signals for your analog devices. It can be in volts, it can be in current. So analog signals represent continuously variable physical quantities: your pressure, your temperature, flow, level, speed. Okay. So, and unlike your digital signals, which have to be either high or low, they have a range of value requiring accurate measurements and mathematical scaling in the PLC program. On Thursday, I discussed that your PLC actually work with the zeros and ones, the bits and the bytes. Okay, so um, your sensors, your transmitters, your analog transmitters are going to convert the physical quantities into an electrical signal, which can be 4 to 20 milliamps, 0 to 20 milliamps, 0 to 10 volts, plus or minus 10 volts. Okay, it will be sent into the PLC via the analog input module. That analog input module is also considered as analog to digital converter. Okay, so what that analog module will do is, now it's going to take your 4 to 20 milliamps that you are supplying to it. It's now going to convert it into digital form, whereby you will now have your 4 to 20 milliamps in zeros and ones. That zeros and ones is now what will be sent into the PLC. Those are the things that will now be updated in the process input image of the PLC. And then you as a programmer will need to now do scaling. Okay, you are going to scale those value into the physical the kind of physical quantities that you have. Are we together? So let's take temperature for example. The 4 to 20 milliamps is coming into the PLC as an electrical signal. Then the ADC, which is the analog input module, converts it into digital format, which is zeros and ones, which can be seen between the value of between the rate of 0 to 32768. Okay, inside the PLC. Those 0 to 32768, that is what you will now make use of in your programming, and scale that 0 to 32768 into your 0 to 100 degrees centigrade. Okay, so and then from there, when you now do your 0 to 100 degrees centigrade, if you have an output which is also analog, you can now say, convert that same thing will be converted into 0 to 32768 on the analog output side. So then that digital format will be converted into 4 to 20 milliamp. If you are using 4 to 20 milliamp, for example, it will be converted to 4 to 20 milliamp current signal on the output side. So that your output module is also considered a digital to analog converter. And then, but after that, it goes to your output to make the necessary changes that needs to be made. Okay, so for your analog signals, you can have 4 to 20 milliamps. For you can have the 0 to 20 milliamps, you can have the 0 to 10 volt DC, you can have positive or negative 10 volt DC. Okay, so but one of them is actually considered is is more used and is more acceptable than the other. Why? Okay, so if you look at the 4 to 20 milliamps, it means that when your variable is at the low end, what gets supplied into the PLC is what? 4 to 4 milliamp. Okay, so whenever nothing, let's say your temperature reading is 0 degrees centigrade now, what gets into the PLC is 4 milliamp. Okay, so you know that at that point that your PLC your temperature is 0. Okay, but when you look at the other ones, let's say 0 to 20 milliamp now, if your temperature is 0, you get 0 milliamp. For the 0 to 10 volt, if your temperature is 0, you get 0 volt. Okay, and then when your temperature is for the plus or minus 10 volt, when your temperature is 0, you will have minus 10 volts. Okay, now what happens if your sensor your sensor is disconnected, or there is a wire break along the line? If there is a wire break, if there is a wire break such that if there is a wire break for a 4 to 20 milliamp transmitter, for example, what your PLC read, what gets to your PLC is 0 milliamp. Okay, so that way it is easy for your PLC to know that there is a wire break here. So because normally at the lowest physical quantity, what I should have is 4 milliamp. Now I am having 0 milliamp. It means there is a what? There is a problem. So it's easy for the PLC to detect there is a problem with the 4 to 20 milliamp. But with the 0 to 20 milliamp and the 0 to 10 volt, if the PLC is at the lowest, what they get is value of 0. What the PLC gets is value of 0. If there is wire break, it still gets what? 0. Okay, so it cannot differentiate whether this is a wire break or actually my my variable is actually at its lowest. Okay, now if you now look at plus or minus 10 volt, okay, you know your lowest might be minus 10 volts, fine. So then minus 9 volts, like that way onto 0. So there is a 0 in that range as well. So there is a 0 volt in that range. So at that 0 volt, that's meant to be like the 50%. When the particular variable, a physical variable, has reached 50% of its value, that's what it's supposed to stand for. However, if there is a wire break, 0 is also the value that gets in. So it means that you can have a wire break and your sensor and your temperature will be saying 50 degrees centigrade. Okay, so which is why the 4 to 20 milliamp is very much uh, as is better than any other one. But that does not mean that when you go to site you cannot have uh, this kind of voltage, this kind of the other analog signals being used. So for example, if you they say use 4 to 20 milliamp is used for process transmitters such as pressure, temperature, flow level. Live zero wire break detectable. 0 milliamp equals what? Fault. Immune to voltage drop over long cable runs. So for this as well, is used by some other instruments and legacy system, full zero base range, no wire break detection. So there's no wire break detection on this as well. So but for 0 to 10 volt DC, it is used for local sensors, VFD speed reference, valve commands, simple wiring, no loop power needed, susceptible to voltage drop on long run. Okay, so and also uh uh and apart from that, it will not help also you cannot dictate wire break with this. So use servo position feedback, the plus or minus 10 volt DC, use servo position feedback bidirectional drives, support bidirectional measurement above and below 0. Okay, for the thermocouple, their use is direct high temperature measurement, the JKTE types, while temperature ranges required cold junction compensation. And then for RTD PT100 and PT1000, they are used for precision temperature measurement, where accuracy and stability is of higher importance, requires 3 to 4 wire connection to eliminate cable resistance error. Okay, so every of the signal type of standard have where they can be used. Okay, but the ones that is mostly acceptable because of the fact that it allows you to detect wire break and it allows easy detection of problem is the 4 to 20 milliamp. I hope that is clear. Any question? Isaiah, Isaiah Elijah.
Yeah, I can hear you. Good morning, everyone.
Good morning.
So, for the, I observed that for the digital input thinking, you are using a sourcing proximity sensor. Now, I've been able to work with most of some of these PLCs, and I've seen, I noticed that we have like a battery symbol here.
Okay.
I noticed that we have a battery symbol here. Does most of those PLCs like have as in a centralized common when you feed, like you feed in, let's just say a negative signal into the common, it can take effect on all the modules, or when you feed, you have to feed negative signal to uh, each data input of the PLC in
Okay.
order to connect
Okay.
the proximity sensor. That's my
Okay.
first question. Then my second question is, I noticed that we have this positive connected to the proximity sensor, the source, the sourcing proximity sensor, yes, in the digital input thinking. I also noticed that this positive, where is it connected to? I'd like to know, because now we have three cables connected to the PLC, and we also have the negative and the positive. We have a battery signal here connecting the negative side and the positive side of the sensor to the battery sign, and the negative and the positive sensor into the PLC. So I want to understand that configuration. Thank you.
Okay. For your first question, um, the the model of the it's not each devices that will now be configured it's not as if each devices we have separate commons. However, uh, there depending on the PLC, there are some, I don't know, they are sometimes broken into groups. such that a common will serve a number of devices, and then another common will serve some other devices. And at times you might have it on that's the normal configuration that you will see. But if it is a very compact PLC that is a small and has a small number of IOs, you can find out that the common is serving all of them. Okay, so but if it has more IOs, they will be in group, and a common will serve a particular group, and while the another common serves the other group. I hope that answers your question one. Okay, and then
Yes, it
your
does.
question two, can you come again so that I can be very clear?
So my question three is, I saw like this battery symbol here. I
Mm,
understand that it indicates a power supply, like a 24
okay,
volt power supply somewhere. I understand that.
okay,
Now, I want to also understand this, because most times when you see a PL, like a connection to the PLC,
okay,
a sensor connection, be it like in this scenario now, a PNP sensor being connected to a
okay,
PLC, you observe that it's just three cables that are going into the PLC. The PLC is getting, you're getting the negative signal and the positive signal into the sensor, and the feedback is now going back into the sensor. So I want to understand whether there is any scenario whereby you connect an external 24 volts into the PLC. I just want to understand, because like I just want to understand. And because after
the
you
scenario
fed
where you
the,
connect an external.
because I know that in the PLC rack you have
Okay.
24 volts power supply
Mm-hmm.
into the CPU. You connect
Mm-hmm.
24 volts that is powering the CPU. Then
Mm-hmm.
now each of the modules might need like a 24 volt signal to power each of the module.
Mm-hmm.
You understand?
Yes.
That's the number one. Now
Mm-hmm.
the for the common, I want to understand, like, after you power the CPU, will you need like this? Will you still need this uh this 24 volt power supply I'm seeing here? Like, will you connect it directly into the common, and after you've
Okay.
like fed the modules, after you
Mm.
fed the modules with 24 volts, would you still
Mm-hmm.
connect this 24 volts into this uh alongside with these sensors? Like, will you still connect it alongside with these sensors uh connection? Like now, this negative side that is connected to the negative side of the PNP sensor, and this positive side that is connected to the positive side of the PNP sensor.
Okay.
Will you still connect these two? Because
Mm.
I don't know, it's kind of, the diagram is kind of contradicting to me.
Okay. So
I don't
I
know. I
I
just
get
want you to bridge that gap.
I
Uh,
get that. It will definitely, just like the name, it may take some time for it to sink in. Okay. Um, Based on your question, you see the power that your CPU is having and can give to the other modules on the rack is sometimes considered the I think the control power. I've forgotten the specific name, but you will understand the concept as I'm trying to explain. And then you can have the load power. Okay, so if you have an application, a very small application, maybe you yourself you are testing out, whereby your PLC, the power you are supplying to the PLC is enough to carry the IOs that you have. Okay, it will look as though the PLC is the one supplying all the power. that is required even for your inputs and your outputs. Okay, so but in a situation whereby uh, you are segregating it so that your loads are having a separate power from whatsoever power the PLC itself is using. This uh, exact configuration is what you are going to have. Apart from the fact that you have powered the PLC terminal has been powered. Are you with me? Apart from the fact that your PLC has been powered, your
Okay.
your sensors will be connected to that power supply this way, and then the common of that power supply will also have to come into the PLC. That is the external power supply that is different from the one that is powering the PLC.
Okay. Okay. Thank you. Thank you
I don't
very
know if
much.
that answers your question. All right.
It has answered. So that means it will work in
No.
situations. This configuration will work in situations whereby maybe let's just say this particular sensor we are trying to consider.
Mm,
Let's just say we have an array of sensors and we are trying to consider the load, the consumption, the power consumption of each
mhm,
of these sensors.
mhm,
We are trying
mhm.
to take into consideration the power consumption of each of these sensors. So the module might not be able to power, like
To
let's
power
just say
it.
we have 15 sensors. The module might
Yeah.
not be able to power all those sensors. So that's why we introduce this
Mhm.
external 24-volt power supply. Okay,
Yeah.
I
Also
understand that
it's also
now.
a recommended standard that your loads will have a separate power supply from your PLC.
Okay, 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 okay. All right, thank you very much. Thank you very much. You've
All right.
answered my
You're
question.
welcome.
Thank you.
Excuse me, can I ask a question?
Yes, you can.
I'm beginning to get bored with this class. The
You
questions are
say?
taking more time than the class is becoming boring. The
Oh,
questions are taking more time than your lectures, sir. I think they should,
uh,
as they have done in other classes, close the comments and mute everybody. You can lecture. People who have questions should jot it down and ask later. We have taken over 2 hours and you're just answering questions. We have not gone like 3 slides. It's boring already. I'm a novice. I want to learn. I'm not here to listen to questions. And to me, their
uh,
questions are recycling on the same thing. They should write it and ask you private, please.
okay, Mr. Kelly. That is well noted. The idea is that we should all understand, but we are going to take that into consideration going forward. Okay, so let's uh, move into the third module. That's ends the second module. Let's move into the third module, which is talking about the programming PLC standards and development interface of Siemens TIA Portal. Okay, so I will start this. Uh, this it will be today will just be brief introduction into this, while my other colleague Olalekan will take over from Tuesday. Okay. All right. So this module is talking about the PLC programming standards and the development interface of Siemens TIA Portal. Okay, so basically you are expected to have a brief understanding of the TIA Portal, how programming is being done there, and then how does the interface looks like. Okay, so at the end of this module, you are expected to know the ISA/ISA 611.313 standards. That is the standards that talks about the programming languages that that we have, and then the um, 611.3.1 itself talks about the PLC as a whole, and then the subsection 3 of it is talking about the programming languages that we have. And then you should also be able to create automation projects using the TIA portal. So why standards matters? Why those standards matter, and what is the story behind the IEC 61131? So before 1993, every PLC manufacturer had a completely proprietary programming language. So an engineer trained on Siemens could not read an Allen Bradley program. Skills were locked to one platform, limiting career mobility and project flexibility. So you can be an automation engineer for your whole life, and then the only PLC you can work with will be the one you have been working with in your uh, previous company. So which also means that uh, if you are changing company, for example, and they are not using the same PLC you are used to, you will have to begin to learn the programming language again. So this is what bets are the 1131 standards, and this is what bets we having a standard programming language that you can use. So as at 1993, IAC 61131 first published, defining 5 standard PLC programming languages for all manufacturers. So they have 5 standards programming languages. We are talking about the ladder logic, we are talking about the statement lists, we are talking about structured text, we are talking about sequential function charts, and we are talking about the function block diagram. So those 5 programming languages were standardized as the programming language that all manufacturers can use or can choose from. So be as it may, you can find out that some of them are just using 3 of it, some of them use uh, maybe all of them are available in some of them, and some are such that for you to use a particular programming language, you may have to have a separate uh, installation for that. Okay, so as of 2003, the second edition published refining language definition and adding object-oriented concepts, and 2013 third edition published IL officially deprecated strong alignment with modern software engineering practice. And today, all major manufacturers, Siemens, Rockwell, Mitsubishi, Schneider Electric, Beckhoff, Fatec, and all the other ones are IEC 61131 compliant. Okay, so but of course, the most common of them, of all the programming languages, which you must see in all of them, is the ladder logic, which is because that it brings a very familiar uh, platform for the electrical engineers or the electromechanical engineers to relate and be able to look into the program and troubleshoot. Okay, so the IEC 61131 is the International Electrotechnical Commission standard for programmable logic controllers. It was known as IEC 1131 before the change in numbering system by IEC. It was developed with the input of vendors, end users, and academics. The IEC 61131 standards consist of 5 parts: the general information about the PLC, the equipment and test requirements, the PLC programming languages, the guidelines, and the communications. Okay, those are the standards that makes up the 61131. So the subsection 1 is the general information, subsection 2 is the equipment and test requirement, 3 PLC programming languages, 4 guidelines, and then 5 communication. Okay, so the IEC 61131 program structure. Okay, so if you look at this picture, you will see configuration in there, and then you see that all this as it is makes up the configuration. You have the communication function, and then you have all these line being defined as a legend. So if you look at this side, they're saying, think about this. The configuration is your factory layout, how your factory is, the how your factory is, that is trying to process your factory into a program. Okay, the resources that you have, which is if you see these resources, is now the machine. What is the this resources is serving as a machine. Then your program is being synonymous to your supervisor, that is checking and then controlling your devices. Then your FB is being seen as the skilled worker with memory, and then FC is being seen as tools. This is just a relational concept, just trying to relate some of the things that you have in your program into uh, into into uh, your plans. Like, okay, this can be seen as this. Now, if you look at the configuration, it houses resource. The resource houses task and program. Okay, so the resource is having tasks. Okay, what do you want to do? Okay, so then the program will be the one to say, okay, well, I want to do this. Then your program will now, your task is what you want to do. Your program is the one that is going to carry out the task that you want to do. So in this case, your task is like calling your program that, okay, this is what I want to do this. Then of course there will be some kind of feedback on the task, so that the task can also call on some other program. Okay, so and then uh so and then there is this this arrow is supposed to be for communication version. I think this picture may not do the justification, a lot of justification for what we are trying to discuss. But let me just paint it this way. In your semantic manager, you have different blocks. You have the OBs, the organization blocks, you have the function blocks, and you have the function. Okay, so now there is OB1, for example, which many of you might be familiar with. The OB1, which is also known as the main OB, or the main execution block, it manages your program. Okay, so it manages your program. Um, you you now have in this case we can put the OB in the place of task. Okay, you can put your OB in the place of task. Are we together? Then the OB, what's the OB doing? OB is definitely responsible for executing your program. So that's why you have this line as the execution control part. So if you have OB here, for example, your OB is going to be the one to call on other program. And that program that is being called on can be your FB or your FC. That is when you write your program in a structured way. Okay, so in some cases, especially when you are just doing a very small program, just to on and off a light, you can write all your program uh inside your OB1. However, if you need to work on a complex project, it's always recommended structure it. And when you are structuring it, the blocks that the blocks you are going to be using are the FB block and the FC block. So the FB and the FC block, in this case now, we consider them as the program. Inside those places are where you are going to be writing your program. Okay, so FB FB has its own memory, where anything that has to do with that particular FB gets stored. It's called DB. It's called the instance DB of that particular FB. So any data that has to do with that FB, the program that is inside that FB gets stored in that instance DB. So it's like a worker that has a retentive memory that remember what happened yesterday, what is currently happening, and can use it to make informed decision. Why FC, you know, they are relating it to a tool because basically you can write program that you write in FB in FC as well. However, they are relating it to a tool because once you use a tool, that's all. Once you use a tool, you return it to where it is. The tool will not remember whatever it is that it did. Okay, it doesn't have a memory. So if we don't want to relate it to a tool, because actually you can write the programs you write in FC inside FB inside FCs as well. So we can call, if FB is skilled worker with memory, you can call FC a a skilled worker without memory. Let me put it that way, without memory, in the sense that it only gets to it's only active, or it only has memory. It can only keep track of the data while that particular FC is being on. Once it is done, it forgets every other thing that it has. So it doesn't have a storage where the activities that went on with it is being stored. So it simply means that if you are working and you want, if you are writing a program that it needs uh, its variables, its values, okay, to be stored in a particular memory, okay, maybe for a particular use, then it is important that you know that you are going to be going with FB. But if you are just writing a program that you don't need to have a memory for, you don't need to try and take track of what is going on within that particular block, then you FC is your go-to uh, block. I hope that explains it. So now, when your PLC is starting up, the operating system of your PLC is going to call on the OBs. At this level, it's going to be called on the OB1. So the OB1 now will now run the program from top to bottom, left to right, like we said, we were explaining yesterday. If you are writing in ladder, so when you call all your FBs and everything in your OB1, your OB will now check. Let's say FB1, what's going on in FB1? Then FB1 will run all its program. When it's done, it will return back to OB. OB1 will run the next one, and that is how it's go. Your OB1 will manage all the program that you have. So in this case, your OB1 serves as a task, that is the work schedule, and then your program, which is your program, will now be written inside your FBs. I hope that that explains it. So you will also have different OBs, different from the OB1. OB1 is not the only OB, but it's the most most used or the most pronounced. The more you go into Siemens PLC programming, you tend to know the other OBs and what they are used for and why they are important to you. So, but it's not only OB1 that you have. You have other OBs. You have OBs that handle uh, 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 time of the day interrupt. You have OBs that handle hardware diagnostics. You have different OBs. So as you proceed in the course, you may likely be shown what those OBs are and how to use some of them. All right. So the IEC 6113130 programming language, uh, like we said, there are five. It's the international standard for programmable logic controller programming language. As such, it specifies the syntax, semantics, and display for the following suite of programming languages. So you have the instruction list, which is also known as statement list. You have the structured text. You have the ladder diagram. You have the function block diagram, and you have the sequential function chart. Okay, so the instruction list can be related to your Pascal program, and then you have the structured text, which is relatable with your high level programming languages, and then the ladder diagram, it's kind of mimics your electronic circuit, and you have the function block diagram as well, and the sequential function chart. Those are the five programming languages by standard of IEC 61131 3. And of course, you know the one that is common, the ladder. But some of these programming languages have their have where have their strength. So there are some places where you when you get to a certain level in your programming, it might be more uh, okay for you to use the like of statement list or structured text than ladder diagram. So as you proceed in your journey in PLC programming, you tend to see where where some of these languages will be more preferable over ladder diagram. All ladder diagram can actually be converted into instruction list or structured text, but not all structured text or instruction list can be converted into ladder diagram. Okay, so um, you have to put that in mind. So, in as much as the ladder helps you to understand and do, in fact, you can do a lot with the ladder diagram without even having to work with the instruction list or structure test. Uh, you and in some cases, if you choose to, you can decide to use different languages for your program. So you can write a particular FB with ladder, write another one with instruction list, write another one with structure text. You can be creative in the way you write your uh in the way you write your program. But if and also there are uh certain customers, okay, that that prefers one language over the other. So some they tell you they use statement list in their own plan. So they want you to write the code in statement list. So some are ladder, so they want to see ladder. Okay, so you have to have that at the back of your mind as well. So at least each and every of these programming language try and have basic understanding of some of them, because uh, apart from the fact that you are going to be writing PLC program as an automation engineer, there are situations where you have to do troubleshooting, where you are not even called to come and write program. The plant is down. Come and troubleshoot. Come and review. Okay, so and then by the time you get there, you call on the program that is inside the PLC. You realize that everything is written in structured text, everything is written in statement list. So if you are only conversant with ladder, that way that might put you back a little bit, but it's not so difficult. If you have your understanding of logic, you should be able to maneuver some of these things. But what I'm saying in essence is, don't limit yourself to ladder. At least have a basic understanding of the statement list and the structure test, the function block, and the sequential function chart, because you don't actually know the challenges that are going to come your way in this journey. Okay, so ISA 6113130 was recommended to ensure consistent implementation and understanding of the coding used to control the process to which the equipment is connected. So this you will agree with me also that the fact that this standard is in play helps you to be able to navigate from one PLC manufacturer to another. So you can spend 10-20 years doing Siemens and you never had any reason to touch Allen Bradley, and all of a sudden you find yourself in an Allen Bradley environment. So yes, you will take some time to adapt, but it won't be very difficult. It will not be as though you are learning from scratch. So because you have an understanding of the language, the only thing you need to get yourself acquainted with is the platform, how the platform looks, how to navigate, all those things. Those are the things you will need to acquaint yourself with when you are changing one platform to another. So at the end of the day, uh, you you are most likely going to work on a number of PLCs. So even if you are learning Siemens today, and then in your company they are using Alembrali, you will still, as far as you are working in Nigeria, you are still going to have reasons to touch some other PLCs. You will touch Omron, you will touch Mitsubishi, you will touch Schneider Electric, you will touch a number of other PLCs. So at this point, you should not be close-minded to, oh, I like Siemens. Siemens is more preferred. So because there are certain I've taken some trainings where, while I was still taking them Siemens, because they started with Alembrali, they believe Alembrali is simpler and then they want to stick to Alembrali. And I've also seen reverse case too, where they Alembrali, because they started with Siemens, they believe Siemens is simpler, so they want to close their mind. So you shouldn't close your mind on anything. uh, anything. You shouldn't close your mind on any OEM, because throughout your career as an automation engineer, you will have to work with more than two OEMs. It might be you working on that OEM strictly, or even interfacing them with one another. So if you ask me which PLC is simpler, or which one PLC is more comfortable, I will say two things. It depends on the one you start with, and or the one you use the most. Okay, so because the one you start with, if you leave it for some time and you are more conversant with the other one, you're most likely going to like the one that you use the most than the one you start with. But if the rate of usage is the same, there is possibility that you like the one that you start with the most, especially when it comes to Siemens and Allen Bradley debates. Okay, so the programming languages. So like we said, we have the five of them: ladder diagram, function block diagram, structure test, statement list, sequential function chart. So the ladder mimics the delay logic control, the contacts. What's going on here? About a minute. Okay, so the ladder diagram mimics relay logic. Your your open contacts, your contacts as input and your coils as output on horizontal rungs. So when it comes to your PLC programming, programming, there are some instructions that you will find in there. You see something like SIC, examine if closed. So examine if closed is also known as normally open contact. Okay, so this is also one of the this year is also one of the confusion that comes in for people who start with Siemens and those people who start with Allen Bradley. So in Allen Bradley, you will see something like XIC, XIO. In Siemens, you might see normally open instruction, or normally open contact, and normally close contact. So because the people want to go with the nomenclature of closed and open alone. So they might be thinking SIO should be normally open and XIC should be normally closed. That's not the case, because one is the naming. One is more like noun, while the other is more like a verb. Okay, so this one now, the XIC is an action, is like a verb, while this one is just a naming. What is the when the contact? It is normally open. That's the name. When you look at it, you see that it is open. Okay, so that's why it is normally open contact. That's the name. Okay, so but when it comes to the action that it does, what does it do? It checks. It checks for a true state. So it examines if closed. Okay, a normally open contact examines if closed. If the contact is closed, it examines if the contact is closed. But for a normally closed contact, it examines if the contact is open. Okay, so like I said, the examine if closed XIC is the normally open contact, and true when bit is 1. So it means when the contact is closed, you have a true value 1. Okay, but when the contact is not closed, you have a false value 0. For the examine if open, it is normally closed contact. What it does is it examines if open. So If it is open, then it gives you a true signal. But if it is closed, sorry, if it examine if it is open. If it is open, you have a true value when the bit is what? When the bit is 0. That is when there is no actuation. But by the time there is actuation, so the value will be false. Okay, and then the value will be it gives you false value when the bit is 1. So your OTE, which is your output call, set bits true when wrong is true. So many of these nomenclatures that you are seeing here speaks more to the Allen Bradley side of thing. So you have the OTE, you have the output large, output on large. So these are retentive output coil. So this one set bits true when the wrong is true. So in the case of Siemens, you will have the coil, or you have the set bit coil, or the reset as well. So when you go into the programming environment, you get to see this well. So this ladder diagram is most intuitive for electrical/relay background engineers, best for discrete control, interlocks, motor logic, emergency stop circuits, supported by all IEC 61133 compliant platform. Okay, so for your function block diagram, signal flows left to right through interconnected graphical blocks. It's and or not XOR shown as standard IEC symbols. Block inputs on left, outputs on right, chain outputs to input. So excellent for PID loops, signal processing, chains, cascade control, used in Siemens CFC continuous function chart for DCS style programming. Intuitive for process/instrument engineers familiar with P and IDs, best for analog processing, PID control, signal routing, cascade loops, less intuitive than ladder for relay style discrete logic. And then for your structured text, it's an high-level textual language, syntax similar to Pascal, C basic, supports your if, then syntax, your for, do, why, do, case of, repeat, until, best for complex math, scaling, recipe management, string handling, most compact language for data intensive logic, require software programming skills, less intuitive for electricians. Siemens calls it SCL, structured control language, best for analog calculation, recipe management, recipe handling, data processing, complex algorithms. And then your sequential function chart, which is also a graphical language for sequential processes based on uh, So based on graph set IEC 848 steps represent process states, what is happening now. Transition, horizontal bars. This is describing how the sequential function chart looks. So then you have the instruction list. It's a low-level textual language similar to your assembly language used for mnemonics, best for direct processor manipulation, register shift, best for analog calculation, recipe handling, data processing, and complex algorithm. This is an example of this. A push button, A not, emergency stop equals machine run. So what this is saying is that if um, when the push button is pressed and when the push button is active and the emergency stop button is not activated, then let the machine run. So that is it. So like I said, you can use this programming language alternatively in your program. So for example, if what you are writing a program that has to do with your motor logic control, you can decide to use your ladder diagram. And then if you are doing PID control, you can use your function block diagram. So if you are trying to manipulate some data inside your program, you can decide to use your structured test. If you are doing your analog value processing, you can decide to use your instruction list if you have a hang on all of them. But if you don't, you can still be able to do a number of things with whichever one that you know and you are conversant with. I think in this course we are going to be taking the ladder diagram. Is there any question? So we wrap up the class today. From the next class, the instructor will start with how you are going to create the project in TI border. So if there is any question, kindly indicate. So we wrap up class here today. Thank you.
Okay, so before we go to questions, if there are any, like us to take attendance real quick. So I'm going to drop the code in the chat now. The code is in chat. For those on YouTube, I've also dropped the code in the chat as well.
Please, the portal is not opening, please. It's just rolling. Thank you.
Okay, so I'll check where that is. So I think we can continue with the questions. Let me talk to the technical guys to know why it's not responding. Is that okay?
All right. Yeah. Abdurrahman.
Okay, so I was just in the class with my friend and I figured out that it's Abaki that is teaching. So this is Khalid from Greenpeg. I just wanted to like reach out.
Khalid, good morning. Good afternoon. How are you doing?
I'm fine, I'm fine. I've just been seeing the whole expatriates pushing out the knowledge to people. Well done, my boss.
All right. Thank you very much.
Yes, thank you.
So if there's anyone with question, the floor is open. Eldon, if you are talking, we can't hear you.
Yes, I was thinking maybe I'm not being permitted. So basically, there are two languages we should learn. The
There are
ladder
two.
structure and there are two parts we should learn: the ladder structure and the instruction list, structured list, right?
No, you you if you have the capacity, you can go ahead and learn the five. But what I'm saying is you should be the let me put it this way. The first time I was going to have to work with statement lists and structured text, I have not learned anything about them. Are you getting my point? So I had to do a little bit of learning before I could uh, catch up. And the two of them were more like troubleshooting work or even upgrade, a project upgrade, moving from one platform to another. Okay. So I'm saying that if you try and have basic understanding of each and every of these programming languages, if you find yourself in such situation, it will be easier for you. However, I personally strongly believe that even if you have a knowledge of the ladder alone, and I believe if you are here, you most likely have done a little bit of programming course, maybe even if it means writing it inside book like we used to do in school. So you might have come across C, Python at one point, maybe not in depthly, and then your logical reasoning should be very, very, very sharp. So I believe you will still be able to make something out of whatever program that you have. But if you have a little bit of basic and foundational knowledge on that programming language itself, then it will help. So if I am to recommend based on the way things are going, if you only have to choose two, I would say you should go with structured test and ladder. So I would say you should go with structured test and ladder, which is also structure is also seen as SCL with Siemens. But if you have a stronger brain, you can go with the five.
Okay, thank you.
You're welcome. I think there is no other question at this point, so I think the only thing left is the attendance. If
Okay, so it's taking a bit longer than planned, right? Unfortunately. So what I would do now is I'm going to share a link to a Google form. You just have to give me a few minutes for that. Right. And then, you know, so just hold on.
Recording in progress.
Hello, please. Good afternoon, everybody.
Hello, good afternoon, sir. Can you hear me?
Hey,
Sorry, please. I need someone to drop the link for the students' portal on the chat. I can't seem to connect, and I need to sign the agenda.
just hold on. Just hold on, yeah.
Hello, sir. Can you hear me, sir?
Can hear you.
Okay, sir, please, since we're waiting for attendance, can I just ask a question?
Yeah, please go ahead.
Okay. My question is pertaining PLC, this class and the last class we had. If, for example, we have a 24 volt power supply to the PLC as an for the PLC, right? So is it possible for it to for the output to be 230? That is PLC to get a 24 volt input and a 230 volt output.
so, I think your question came from when I was explaining the 1200 PLC DC relay, if I am correct. So where I say the relay can
Okay.
either be for the 24 volt or your AC voltage. No, you can't supply 24 volts to your PLC and then expect uh, uh, a 220 volt. It's not possible. So what happens in the case of the relay? Let's say you have a DC relay PLC, DC input, which is 24 volts. Your input device is also using 24 volts, and then you have a relay. But in your own case, you have an output, okay, that has to be 220 volts. So the power supply for that output will be different from that of the PLC. Are you with me? So when you are doing your wiring, the
Yes, I'm
same
with
way
you. I'm with you.
if you, when we are explaining the circuit and sourcing, you see the way the wiring is done to the power supply. You are going to do the same wiring with reference to the power supply that can supply you 220 volts for that relay output. So it is not your PLC
Okay.
that will give you the 220. It is you have a power supply that can supply the 220. So I don't know. If let me share this screen again. Let's see. So you can.
Okay.
Sorry, I just shared a link to a Google form. So we're all just required to fill in our name, email address, and then the code that I also shared as well. So I'm going to do that on YouTube now. So on YouTube, you can also just check it.
So Edosa,
I'm
so
with you,
you
sir.
see, in this case now, this is your load. So this is your output
Yes,
that require the 230
yes.
volt. So the PLC itself will have been powered in its terminal, which is 24 volt. But you see this power supply in this case will now be a 220 volt power supply.
Okay.
I hope that where the PLC will have its own 24 volt supply to it separately, but for the purpose of your load, which is a relay output, you will now have this power supply, this external power supply to be a 24 volt. So and sorry, 220 volt. And in this case, what you will have is live and what and neutral.
Okay. 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 So it's not possible to have a 12 volts and output of the 220 volts. Okay, sir. Okay, sir.
From your PLC, no, it's not possible.
Then, okay, sir. Okay, sir. So and again, please, sir, what should I consider in PLC one? And for example, if I'm using an a Siemens, are you with me, sir?
I'm with you. I'm with you.
Can you hear me?
I'm with you. I can hear you. I can hear you.
Okay. For example, I'm using a Siemens PLC, and I want
Okay.
to change to Allen Bradley, for example. What do I need to consider? What do I consider when choosing this kind of choosing a PLC, please?
Okay, so you have Siemens and you want to bring it into you want to change the system to Allen Bradley.
Yes. For example, okay, for instance, my first question is, what do I need to consider when choosing a PLC?
Okay.
Secondly, can I do that? What I just said? Can I change from this PLC just like that, or I need to consider some things to change?
Okay, you can change your PLC if you want to. Some clients the clients require that you change it, fine. And if you want to be a marketer of another PLC too, maybe your company use a particular PLC because of partnership, you want to recommend to the client,
Yeah.
you can decide to change it if the client accepts that you change it. So, but what will you now consider? So, in choosing a PLC, you need to consider the application. Okay, so for
Okay.
example, is the PLC basically going to be taking care of your instrumentations? Is it going to be for motor control? Is it going to be for high speed control? Is it going to be what exactly is the application that you are going to be using it for? Okay, so and is it
Okay.
actually for safety? Is it a system that is very safety conscious? So I remember at the few time I was able to join the first instructors class, he was explaining that you have PLC, Siemens PLC, the one with F, which is fail safe for safety, the one with T, which is for
Yeah.
technology and the likes. Okay, so you will not have an application that has to do with servo or stepper motor, and then you just decide to go and choose any PLC. You will want to go for a PLC, a technology PLC that can handle high speed control, or at least even if the PLC cannot handle it, it can accommodate a module that can handle that high speed control. So you need to consider the application. Then you need to consider the IOs that you have. What's the number of IOs? Is it a small system that
Okay.
has just 18 input and 4 output? Is it one that has a whole number of inputs? Maybe it has like 100 inputs and then has another 20, 50 output. So you need to consider the number of IOs. You also need to consider what's the power rating of my devices. Okay, so why you need to consider that, of course, by standard, you need to separate the power supply of your PLC from that of your load. So by the time you have decided the number of IOs that you have, you need to check the load of your PLC, because that will, of your devices, because that will help you in selecting even the power supply that you need to use. Okay, so those are the things that you need to consider: the application, the complexity of the process in terms of what's the number of IOs that you have, then the power rating of your feed devices. You need to consider those things. So, but when it now comes to you migrating from one PLC to another, so uh, already you know the application, you know, because by default you already know what the PLC is doing. You know the number of IOs that it has. So you know you definitely also know the power rating of the devices that are connected to that devices. So it's a matter of, is it a modular PLC or a compact PLC? So if a compact PLC, you know you are replacing it with a compact PLC that can do the same work. And then if it's a modular PLC, you know you have to replace it with the same thing. So if you have a configuration where you are using an SM1500 PLC now, and then you have about let's say 10 modules connected to 10 modules connected to it, you know that you can be going with a control logics in Allen Bradley that has the same capacity. So you need to check the capacity of your CPU and all in terms of the RAM, the processing speed, and all those things. So you look at it, and then you look at the equivalent in Allen Bradley that has the same capacity, that so that it can fit into your work. So if you have an S715 that is doing about that has about 10 modules, you can go for an Allen Bradley controllers, maybe with 17 chassis. Okay, with 17 chassis, and can accommodate the same number of input and output. So, and if uh, the Siemens is used for motion control, it means that the PLC you are selecting on the Allen Bradley side too must enable motion control. Okay, if it's a safety PLC, you know you are supposed to be going with guard logics on the Allen Bradley end. And uh, if the setup is a distributed setup where you have your CPU connected to ETs, you know that on the Allen Bradley end you can decide to choose a controller that is connected with flex IOs. So that is just, you just need to know the existing automation architecture. What are the things that it's having? What are the features of the PLC, the CPU, the modules that it's having? What are the features? Then you select the uh, equivalent in the other OEM. I hope that is clear.
Yes, sir. Yes, sir.
So, but be as it may, whatever it is you are doing, if you are changing from OEM to OEM, it may seem you might end up and having to write your program from scratch. Okay, so
Okay.
because to the best of my knowledge, I don't think there is any platform or application that can help you convert a Siemens program to Allen Bradley directly. So although you can check through the program and use it to uh, write your code, or better still, you get the control philosophy of the plant and then use it to write your own program separately. But if you are moving from one OEM to another, maybe you are moving from 300 to 1500 or 1200, you can do migration on TIA portal. So the same thing for Allen Bradley. If you are moving from their old L555 now, or the L61, you can do migration from the migration of the program into the Studio 5000, so that you can still be able to make use of that program that was on the other one. But if it is one OEM to another, you may have to write your program from scratch.
Okay, sir.
All right. Musa
Thank
Idris,
you very much, sir.
you're welcome.
All right. Thank you very much. So sorry, my question, I just want to ask for the previous class that we did. I hope you can hear me.
Yeah, I can hear you.
Okay, so my question is based on the last class that we did on the data type. So I don't
Okay.
know for the case of let's say like timer, counters, I don't know which kind of data type are they going to be under. Is it going to be integer or another data type? I don't know.
You see, timer itself is considered a data type. Counter is considered a data type, but they
Okay,
might they will definitely, they are data types that houses some other data types. Okay,
okay,
so
okay,
for like the enable time, the downtime, they are boolean value, and then your preset value or your set value, they will be integer value. Okay,
okay,
so you have beyond your normal data type, bits and by boolean, real, float, you have array. Okay, which can be
okay,
it's also a data type. It can be array of integers, array of floating point number, array uh, of boolean values, and then you have what we call the structure struct or structure data type. In this case, where it's a combination of one of different type of boolean of data type into one. So like your timer now can be seen as such because it's having boolean data type, it's having integer data type housed into it. So you can create a data type that that is okay. You can also create a user defined data type, which is to, let's say, monitor the status and control your motor, for example. So, and in that case, you might be taking into record the start and stop of the motor. You can be taking into record the speed of the motor, the current of the motor, the frequency of the motor, the voltage of the motor. So when you have a particular data type that is housing that, you call them it is considered a UDT, user defined data type. So in the case of timer and counter, they are uh, data types on their own, but they have some other data types embedded in them.
okay, okay. Sorry. So is it also the same with like this function like move, equal, greater than, all these
Mo-
functions? Is it also the
Move,
same?
move equal are instructions. They are instructions. Okay, those equal to, greater than, less than are comparator or comparative instructions. They are just instructions. They are not data type.
Okay, okay. Thank you very much.
Okay, you're
Yeah.
welcome. I would like, okay, Temidayo Oni. Please go ahead, Temidayo.
Okay. Good morning, sir. Good afternoon, sir.
Good
Can you hear me, sir?
afternoon. Yes, I can hear you.
Can you hear me, sir?
I can hear you.
Good afternoon, sir. How are you, sir? Yes, sir.
I'm doing good.
Thanks for the training, sir. So, my question is, speaking of ETs, right? I would like to know, are they like a POC on their own, or is it
Okay.
more like we are just extending modules? Do they also have processing capacity, or can you now using a normal PLC like we all know, sir?
Okay, there are different types of them. There are some of them that serve as that as CPU themselves. They serve as the CPU. They serve as PLC on their own. While there are some that require that are just a distributed system. They require control from a particular from a CPU. So there are some of them that can stand alone as a controller. I hope you got that.
All right, all right. Yes, I get that, sir. Thank you very much.
You're welcome. Okay. Dios, please confirm that the attendance has been taken care of and we can end the class.
Okay. Hi.
Oh, okay.
Yeah, please, can you explain UDTs, the right time to make use of it? Is it something that someone can always use in probably every program the person wants to write? And also, could you please also differentiate that between that and DBs as well?
Okay. So, well, this will be addressed during the course of the program, I believe. However, UDTs, you can decide to UDTs, like the name implies, user defined data type, you can create them. I make an example of a motor now. You can decide to create a UDT for your motor, whereby you are that particular uh, UDT is to take care of anything that has to do with your motor, the current, the voltage, and the off. Now, when it now comes to DB, DB is inside DB you can create some of this, you can create something like that inside DBs as well. However, they are for DB, it goes beyond you having different data types in it. It's a storage area. Okay, so UDT can be created to be used inside your program at any point. You can even use them inside your FBs. You can also call them inside your inside your DBs. But the use UDT is not going to be storing any value for you. Okay, so it is just going to be it is just there to keep to enable you to use them within your program. But in your data block, you have your values will be stored very well in the data block. Now, where Unity comes to help you is that, let's say, like the example of motor that I said now, let's say you have like 20 motors that you want uh uh to control or take monitor their status and all. Instead of you going into your DB directly and creating a structure for that motor, you can create a UDT. So if you create it inside DB directly, it means that you will have to recreate it again for each and every of the motor inside your DB. But if you already create a UDT, you can just call on that UDT inside your DB and assign it to each and every of your motor. Okay, instead of you having to recreate them one after the other. I hope that explanation is clear.
Yes, that makes sense. Thank you.
Right. You're welcome. All right. I think we can end the class at this point. If there is any other question after this, you can reach out to me on WhatsApp or on any of our platforms. Will definitely be attended to. And till Tuesday, when you will be having the next instructor, I say enjoy the rest of your day
Hello,
and
sir. Hello, sir.
enjoy the week ahead.
Hello, please. I've not marked my attendance. I don't know what's happening. I've not gotten the code yet.
Hello.
Okay, they will attend to you on that. They will attend to
Hello.
you.
Hello. Hello.
Andrew,
Yeah, please, what's your name on the chat? so that we can.
Abdubaki Olaoye. Abdubaki Olaoye.
The same name. Okay.
Yes, the same name.
Okay. Thank you very much.
Yes, sir.